Good morning, everyone. Good afternoon. This is Dr. Nat. We are going to continue with our lab, which is now on Lab 6 activities, AutoCAD. So before we start, as usual, after you have started on your lab activity, I expect you to upload it on Padlet. The link is given over here. Okay, and then the next one is how to submit the assignment. But for Lab 6, we do not have assignment. So we will start with activity 1. So for activity 1, let's take a look at this first. Let me make this bigger. So for activity 1, we are going to do bearing unit part 7 and 8, which is an M6 hexagon bolt. So an M6 hexagon bolt, let's try to Google what that means. Okay, so I Googled M6 hexagonal bolt, and this is what I found. So here is the bolt size chart page by Electronics Hub, which I already pasted in your PDF Lab 6, okay? So here it gives us an introduction to bolts, nuts and washers, but we are only interested in this guy for now. And here it gives us the types of bolt materials. We are also not interested in that. The common types of bolts. And then here is what we're interested in, which is the bolt dimensions. So here we can see that we have a dimension for B, dimension for A. B is actually across corners, A is across flats, C is the head height of this hexagonal bolt. Then we have the thread length. We are not doing the thread for this part, but we are doing the overall length, which is 25 millimeters. And then we have the bolt diameter, which is going to be the same number or the same measurement as the grade of this bolt. The grade of this bolt is called M6. Therefore, it means that the bolt has a diameter for this D is equivalent to 6 millimeters. Okay? So now, how do I know what the measurements are? So here they give us this table, imperial bolt size chart, which is in inches. We are interested in millimeters, so let's scroll down if we can find anything in millimeters. This is called the metric bolt size chart. We are interested to use dimensions in metric, so this is the table that we are going to use. So M indicates the bolt uses metric thread. 6 indicates the nominal diameter of the bolt at the shank of the threads. And then 1.0 indicates the thread pitch of the bolt in millimeter, and 20 indicates the length of the bolt in millimeter. So now let's take a look at our what we need to draw, which is the part 7, 25 millimeter M6 hexagon bolt. So we are given the length of this bolt over here, which is 25, and we know that it is M6. So how should we describe this hexagon bolt? Would be M6-1.0 times 25, which indicates the length of the bolt in millimeter. Okay, so we are looking into M6. The pitch thread is 1 millimeter, across flats is 10, minimum is 9.78. So they give you this tolerance. But for AutoCAD, I want you to follow the maximum measurement. And then across corners is 11.5. Then head height is 4. And then the bolt diameter will follow this value, which is 6. For if we are talking about M8, then the bolt diameter D will be 8. Okay. Again, we are doing M6 only. So the first thing that I want to do is actually check on the dimensions of this hexagon. So if we look at the slides, it is given that A is, what is A? A is 10. A is 10, right? And B is 11.5, which means that this is the longer side and this is the short side. The longer side is from here to here, and the short side is between two flat edges. So between A flat edge of this guy, flat edge of this guy is A. Whereas for B, it is from the pointy side to the pointy side. Now, let's take a look at our diagram again. So here, from the pointy side to the pointy side, it should be 11.5. From here to here, it should be, from the flat side to the flat side, it should be 10. Okay, so this is what we have in mind. So let's go back to our AutoCAD. So now I'm going to make a line to guide me in making this hexagon. So 11.5. And then I'm going to find the midpoint. Try to remove nearest. Is midpoint here? It's here. Okay, I think this is good. Now finding the midpoint. How do I know it's the midpoint? It tells me there midpoint, or it shows me a triangle. So 10 divided by 2 is 5. So 5 on one side and 5 on the other. Now you don't have to do this if it is not necessary for you, but I would like to have a guideline on how to make my hexagon. Okay, so the next thing is to make the hexagon shape. We have the square or the rectangle, we have the circle. So what function should we use when we are making polygon? Oh, sorry, hexagon. I already gave you the answer. So the answer is polygon. So the number of sides is going to be 6. And then I'm going to specify the center of this polygon. Now I'm just going to circumscribe about circle, because basically we don't really have a circle. So I'm just going to try to fit this in. Basically, we know that the flat side should be over here, and now it is aligned. Now let's try to remove the lines and measure this, if this is accurate or not. So I'm going to use dim from this point to this point. It should be 11.5. Why is it 11.55? It means that something is wrong. Okay, and again, let's try to find out the dimension for this guy. Flat side to flat side is 10, so we got this one right, but the pointy side to the pointy side is not correct. So let's try to do this again. I'm going to remove this and try to measure this. Is this really 11.5? So the length shown here is 11.5. It's just that I did not follow this point to point. So let's try again. Enter, specify, and inscribe in a circle. So remember, the pointy side is this way. It seems that it's not snapping. The pointy side should snap. Okay, so this is snapping. I don't know if this is correct, but we can measure. So let's try to measure from this point to this point is now 11.5, and another dim from this point to this point should be 10. So it did not follow through. Let's try again. So I'm going to remove this. Escape. Try again. So basically you want them to snap. Okay, let's try to utilize this. Using, what should we use? Let's try to use perpendicular is not it. Apparent intersection. Okay, let's try that. Okay, number of sides. So we are going to inscribe in circle. So everything looks correct. Basically, I want them to snap. Okay, so this is 10. We got that part. And then we want this part. Okay, so we got 11.5. Now, that took a long time to just make an accurate polygon. So the issue was that I don't know what the size of the circle is. But the tip to doing this is to make a guideline and having your hexagon to snap exactly at the end of the line. So hopefully you can try that. Okay, to make the right side of this bolt, I'm going to make a rectangle for this part. So this rectangle is going to be 11.5 on this side, and C will be 4. So 11.5 and 4, and then we have a D which is 6, and then this is going to be 25. So 2 rectangles, and this is going to meet at the midpoint. So let's continue with that. So I'm going to make like a guideline using my center, just a guideline, and then I'm going to remove it later because basically I want it to be 11.5 and aligned over here. Okay, and then I'm going to use my default layer, which is for the visible line. I forgot to trim this guy out. Okay, alright, so now I'm going to make my rectangle in default layer. It doesn't have to be in the midpoint. Oops. Okay, I'm going to make a line. I don't want this midpoint, so I'm going to turn it off. I'm going to turn off the midpoint. Let's try doing it over here. Oopsie. So that is going to be 11.5, and then it's going to be 4. It's going to be a 4, and just making a regular rectangle right now. Okay, so that is my first rectangle. Then the next rectangle, I want it to intersect at the midpoint. So I'm going to find the midpoint first. And then my rectangle is 6 by 25. So up by 3, and then 25, and then down by 6. Then just completing this rectangle as usual. Now I can remove this guy or not. Let's just remove it for now. So I have that in place. So let's find out the dimensions first. This should be 6, and this should be 11.5. Okay, going back to the slide. So now we have these things, but it did not specify what these things, what are the dimensions of these things. Okay, so if I were to try to figure this out, I can see that it is somewhat aligned to this flat side. Do you see it? Okay, so we are going to follow that, then make an arc for this. And you can see over here we have like some sort of a chamfer. It's not a fillet, it's a chamfer because it is very it is very sharp. And for this guy, we're not going to do the threading, but we are going to have a little bit of chamfer over here. Okay, so let's do our chamfer. So select the first line. Right now I don't know what the chamfer distance is, so after I've typed in chamfer in the command box, you can see that if you want to specify the distance, you can click on you can type in capital D. Okay, so here it gives you the first chamfer distance. In this case it is 1. Maybe you want to try 0.5, maybe you want to try 2. Here I'm just going to use 1 for now, and then the second distance is going to be 1, and then I am going to do it like so. And then here you can see the command box is gone. I mean the function is no longer there, but if I click on enter, I will see chamfer function again. So I'm going to do that again, right, like so. Okay, for this guy over here, I'm going to change the chamfer distance to be 0.5 by 0.5. So again, I'm going to click on enter, which gives me my chamfer function, and then type in capital D, 0.5 for my distance number 1, 0.5 for my distance number 2. and this is where what I'm doing right now. Okay, so you can see that the dimension of this guy is now 5.5 because it's measuring from here to here. You want to adjust this to measure from here, so it is still 6. Okay, so that is what we have so far. And then I would want to offset by 1 down here, offset by 1 down here to make my 3, what do you call this? 3 arcs. There's not really an offset from here to here, but you can see that it's slightly smaller. Maybe 0.5 would be sufficient. Let's try to offset that. So I'm going to specify the distance, 0.5, select object to offset, enter again, select object to offset. So selecting this guy, offset distance, going inside. Okay, so now I am going to extend this line because I am very lazy. Okay, like so, and then this guy, extending it. And now I am ready to make my arcs. Okay, so we have several ways to do this. We can make an arc, but this is not really a circle, right? And we can also make an ellipse. Since this is not really a circle, it does look like an ellipse. Now, if I were to look at a more accurate diagram, it looks like it's just rounded. Okay, let's try to make the circle first. Arc. So what I'm doing here is I made a line that intersects this midpoint. So as you can see here, if I make a line, it is intersecting the midpoint between here and here. This line all the way from here to here, and I found the midpoint. Same case over here, or you can just mirror it. So now what I want to do, why I need this midpoint is because I want to try the 3-point arc. So here we know that arcs have different variations. So here I want to use the 3 points arc, and I'm going to specify here as my first point, and then this is going to be my second point, and this is going to be, I want this to be aligned. It's going to be my third point. Okay, so it overlaps slightly, which means that we need to change our chamfer later. Okay, and then for the next one, I'm just going to repeat this process. I want this to be exactly at the point that I ended the first arc, and then going to find the midpoint of this guy. And again, I'm going to try to align this to what I started earlier. Let's see where it's not detecting. Okay, now it is. Come on. Okay, so you want it to snap like that. Okay, same thing again. You want to start where you ended, find the midpoint, which in this case is here, and then here is where you ended. Okay, so I believe we should change our chamfer. Okay, so here, can we change it over here? Not really. So what I need to do is actually make a rectangle first. Okay, because the chamfer is obviously not working for our arc. Okay, so I've connected the lines again. So now I'm going to make my chamfer slightly smaller. Just now it was 1, so now I'm typing capital D, and the first distance of the chamfer, let's go with 0.75 and 0.75. Okay, so this is going to be it. Okay, so 0.75 does not really overlap. So let's try another value, maybe 0.6. Going to specify 0.6. This is going to Yeah, what was I thinking? It should be 0.8. Should be bigger. Okay, chamfer 0. What was it? Distance 0.8. Let's try that and see if that is much better. Okay, so it's slightly overlapping compared to the 1 that we had. So we can try again until we get a suitable value. I'm going to try one more time and then I'm just going to whatever it. So the distance is going to be 0.85, 0.85. Okay, so this is what I have so far. Looks okay. And then what else? Let's see. For this guy, it's pretty much done. You can see that there's like a slight gap. So this is not accurate, right? Ha ha ha. Okay, so what we can do here is actually move this. Okay, I am going to not move it. I'm going to make an offset and try to align the arc to the offset. So my distance would be 0.1 maybe. And I'm going to select this object and try to offset. So that's kind of too small. 0.2. Okay, 0.2. So distance 0.2. Select object. Okay, I think 0.2 is okay. Let's see if that looks sufficient. Yeah, it does. So again, I'm going to adjust this arc. Okay, let's see if that's possible. So now I want this arc to touch that. So clicking on this arc. Wait, I'm not clicking on the arc yet. Wait, I just want to select the arc, right? Okay, bringing this forward, like so. And then again, the arc, clicking on that, like so. Okay, so now I can remove this line. Now it looks okay. So again, let's take a look. It does look good, but this one is actually joining. Let's see if we can adjust that. Okay, I managed to adjust that. And this guy. Okay. And these guys, let's move it a bit upwards. Just slightly. Okay, now it looks much better. Extend this line to intersect. Okay, so you see, even doing a hexagon bolt is a nightmare. So imagine like all the complicated parts. But this is where your skill will be useful in the automotive industry, in machinery industry, and so on. Okay, so that's part number 1. So I'm going to remove this guideline, and since this is a rounded bolt, we will need to have our center line. Okay, and the center line will be at the midpoint. Oops, sorry, I forgot. We cannot extend the center line to 2 diagrams. And the center line should only extend by 0.3 millimeters. Sorry, it should only extend by 3 millimeters from the actual object. Okay, so for example, I have my center line this much. Now I would lengthen it by 3. Like so, and over here, lengthen it by 3. So that is your center line. Okay, since this object is rather small, that is why we can't really see the, what is this? We can't really see our, the center line, the dashes, right? Okay, so that is your center line. The next one for this guy over here. oops, I want to make it the same size as my object, like so. And then I'm going to extend it or lengthen it by 3 on one side and 3 on the other side. Same case over here. Okay, enter, and then I'm going to lengthen it by 3, lengthen it by 3, Okay, so that tells me this object is actually rounded. And then I'm also missing a circle inside of this. So now I want to work in the default. So I'm just trying to make a circle 4.6. Okay, so how do I know the circle is 4.6? I saw it here, and it is 4.6. Okay, so there you have it, your dimensions and your first part for today's lab. Thank you. I'll see you in the next part.